Hi, I'm Dr. Hay. I'm going to tell you how to use the Biot Savart Law. The Biot Savart Law is used to find the magnetic field near a steady line of current. And it looks like this. Now let me tell you about the pieces in the Biot Savart Law. Out of the front of the integral, you've got constants. So these are some constants. This is mu naught over 4 pi. Now to tell you what's inside the integral, we've got to draw a diagram. Let's say in general you're trying to find the magnetic field near a line of current, and that line of current maybe looks like this. And I realize that this is a constant current, so it's useful to be able to take I out of the integral. But I leave it here next to the dl because I want you to think of I dl as an element of current. I traveling along a line of little bit of length L. So here's some I dl, some current traveling along a little bit of length here. Now, if we want to find B at a distance r away from this little bit of current, we may want to define a vector r to some point, and at this point we're trying to find the magnetic field B. Now it's handy to define also an angle here, even though there's not an angle in this equation, but notice that there's a cross product between I dl and r hat. And when you have a cross product, it's convenient to have an angle between those two vectors. So let's put this angle, let's call that angle theta, and you'll see in a moment why that's useful. The Biot Savart law is used similarly to the Coulomb's law in electrostatics. So if you're given a current configuration out of constant current, you can use the Biot Savart law to find the magnetic field near that current, just like you could use Coulomb's law to find the electric field near a charge configuration, like a charge density configuration.